Okay, so we can review. What do we do this week? So we talked about expressions. I went ahead and covered the highlights that I feel can get you while you're programming. So uh, that's why I covered data type conversion and typecasting. So if you are working with integers and doubles and you assign like a double to an integer or you assign an integer to a double, then it's important to understand what happens. Not only that, like if you are performing arithmetic operations on them. So we went over the rule that discusses how an integer is converted to a double by C++. You don't have to do anything. And how a double is converted to an integer by C++. You don't have to do anything. We talked about times when you have to explicitly convert data types by using static cast. And we went over one example, but the example will work for most data types. I talked about the dangers of overflow and underflow. So if you have a number that is not supported by the data type you are using, then you get inconsistent, weird results, and more than likely your program will not produce correct results. And that's even if your test cases pass, because maybe during your test cases you're not using large enough numbers. And then we talked about constants and how to use them. Constants are read-only variables that get a value when the program starts running, and the only other time you can change it is if you change the code and stop the program and run the program again. And this other multiply and combine assignment operations, these ones were supported in Python. These ones are supported in C++. This means that you add one to the value of the current var being a variable, and this one you deduct one, so incrementer, decrementer. We also went ahead and started talking about uh, logic, and we talked about George Boole, a very important mathematician in our uh, computer industry. He developed Boolean logic, and he developed the foundation for information that was actually not discovered. So he passed in 1860, and the connection between Boolean logic and information and computers was really not made like until the 1940s by Claude Shannon, an MIT and University of Michigan student and MIT researcher. So it's important to understand Boole wrote The Math Analysis of Logic and The Laws of Thought. These two books, the foundation for Boolean algebra. He didn't have formal education. However, he was a genius in his own right. So he developed the truth tables, and he had very simple uh, logic. Like any value can either be true or false, or 0 or 1. And from there, he went ahead and developed the truth tables, right? So if you want to compare two logic Boolean expressions, then if either one of them is false, then it's false. And both of them have to be true to be true in the end. And in the or, either one of them can be true, and then it's true, and both of them have to be false to be false. So it's important. If you understand the truth tables, then you don't have to be guessing when you are creating Boolean expressions for programming. And then the not operator. So false becomes true, true becomes false. These are important, and when you're like excluding or the easiest expression returns false, and then you not it, and then you can create your expression. We'll go over some of these examples in class this week. And the symbols and, or not, so double ampersand for and, double a pipe for or, and not is the exclamation point. Okay, and this is what we went over. We talked about the if statement. So the if statement in its simplest form takes a Boolean expression, and then it has a block of code. The curly braces are optional. My recommendation is pretend they are required, and you'll never stumble across issues in the future. The else performs if this is not the case, so then this block executes. And then we have the if else if, which we did have a an example of when the if-else if just gives us more than 2 branches, okay? So here it is. Let me see. If-else if, right? So if, else if, else. So there could be more than one else if. And notice the else, no condition here, if a condition here, Boolean expression, right? Boolean expression. And then we talked about the switch statement. This requires a value that evaluates to an integer, and we learned about the importance of break. So if you omit break, then this code executes, and then this code executes, and then it finally breaks. So you have to be very careful with the switch statement. I will talk about the immediate if. It's a shortcut if. Here's the syntax for it. Okay, and then of course we talked about the operations, right? So less than, greater than, less than equal to, greater than equal to, logical operators. There we go. Okay, we also had an assignment, have an assignment with if statements for this week. So I just want to point out some things here. So you will be creating code that implements this table, right? So if the grade is between including 90 to 100 and A, and then B, C, D, and F, and you will be using if statements or if else if for this one. I've given you guidance for that, so you follow these instructions, right? So you use if else if, and then you do the same thing, but get letter grade using a switch and given a numerical grade. So this one, getting letter grade using if shouldn't be too difficult, right? Because you compare a range. And you can also compare a range with a switch. So here you have 2 options. You can go on the internet and find out how to get a range with switch, how to compare a range, or you can do some math to convert this to single digits by math division. And then you can narrow down the switch to very few options. But it's up to you. Like I'll leave it up to you, right? So if you do not use the range switch, then you have to remember how to use the break to make sure that a block of statements execute together. Okay. And then I give you values that you need to test. And of course, you need to write code, then write the test case, and then finally write your main. Okay, so that's what this assignment will cover. Okay, for next week, we want to make sure that you cover chapter 5. So read chapter 5 from Gaddis or 9th edition, 10th or 9th edition. If you're using the free Fundamental C++ book, then read chapter 6, which covers looping. I think that'll keep us busy for this week. We may get into functions, so I would just glance at chapter 6 also, and let me see, in chapter 9 in the free book. So chapter 6 in Gaddis, chapter 9, okay. And there will be a quiz this coming week. There'll be assignments, so I'll be ready to come to class and work. And have a good weekend.